Hey all, I'm gonna try to go a little faster this time. I recorded this whole video, but the sound I kept putting, thought I had my headphones on, and I kept putting my hand over the speaker, so my bad. Exponential growth and decay. We're gonna do two videos, one today, one tomorrow. This one will be basically on all the basics. Tomorrow will be a little bit about the graphs, and I'll also spend a little bit more time doing some of the harder, more elevated level problems. So exponential growth and decay. I know if you're looking at it, and I made a typo here. This has to be fixed. It's going to be b equals 1 plus the percent, and this should be b equals 1 minus the percent. Okay. But if you're looking at the formula quickly, exponential growth and decay, the formulas pretty much look exactly the same. In these two formulas, obviously, again, they're the same. When it comes to growth and decay, the A in the formula is the starting amount. Next, we have the B. The B is going to be, you can call it a few things. Some worksheets and etc. call it the multiplier. Other worksheets, and I tend to call it the growth or decay factor. And then the last thing, the X in the formula, is the time. Depending on the specific problem, the time could be years, it could be seconds, it could be months, it could be, minutes. It depends on what it is. It could say like the population of gnats multiplies like, 1 per second. Who knows? I'm just making up things. Per second, it could be per minute. So depending on whatever, that's what the time will be. Now the thing that changes, that differentiates that's between exponential growth and decay, is solely the value of b. If b is greater than 1, that's when we're talking about growth. And basically that just means it's getting bigger. So if you see something that says it increases, etc., then you're going to be adding the percentage. Let's say we had something like 18% and it's an increase. I just want to show you what that would look like. You wouldn't do 1 plus 18 and then have b a b value. That's incorrect. That's not the way this should be done. When you're trying to do b, it's going to be the percentage, but it's the percentage in decimal. So it's going to be 1 plus, hopefully everyone remembers how to turn a decimal. You move it 2 times to the left. So it'll be 1 plus 0.8. So this will be 1.18 for the b value. But as long as the b value is greater than 1, that's how you know you're dealing with growth. If it's less than 1, that's when we know we're dealing with decay. And in that case, let's use the same 18%, but again, instead of increase, it'll say something like 18% decrease. And if it's a decrease, you're going to, again, do the same thing. It's going to be 1 minus the percent in decimal form, again, not regular, and that's going to be 0.82. So B for this case would be 0.82. All right, so we're going to look at a few things that'll build towards what we want to do, the actual solving process. But just a few things before we get too far. If you had like 8%, you would still move it, just want to clarify, you would still move the decimal 2 times to the left, and that would be 0.08. If you had 125%, again, you would still only move it 2 times, so it would be, 1.25. Here it is. Okay. 1.25 would be there, etc. So just keep that in mind, that it's still always 2 times to the left, regardless to whether it's going to be a 0 in front or a whole number in front. All right, so the first set of questions here is just saying, given that the growth or decay percentage, determine the multiplier. So the multiplier is, again, your B. So basically, they just want you to figure out what is B. All right. Excuse me. So if it is growth, it's going to be b equals 1 plus the percent. So this will be 1 plus 2 times to the left will be 0.05. So this is going to be 1.05. Decay is going to be b equals 1 minus the percent. So it'll be 1 minus 0.12. Again, 2 times to the left. And that'll be 0.88. Excuse me. For 200% growth, it's going to be b equals 1 plus, again, the percent. So it's going to be 1 plus, it's here, 2 times to the left. It's going to be 1 plus 2. So it's going to be 3. And the last one is, again, decay. So it's going to be b equals 1 minus the percent. That's going to be 1 minus, again, still 2 times to the left. It doesn't matter that it's already a decimal. If it's in percent form, you always have to go 2 times to the left. So 0.00, excuse me, 85. So when you subtract, it's going to be 0.9915. All right, so let's go to the next group of questions. Now, for this next group of questions, it's just asking you, based on the equation, do we have growth or do we have decay? So the key thing to keep in mind, the thing that'll just be able to determine this for us is the b. If b is greater than 1, it's growth. And if b is less than 1, it's decay. Now, these problems look a little different than the equations, in the beginning where it says a. But, excuse me. The key thing to remember here is that b is the thing that's going to the power. So whatever thing is going to the power is b. All right, so b is to the power. So when we look at the first one, number 3, b is therefore 3 because that's the thing that's going to the power. So 3 is greater than 1, so this is growth. For number 6, we have 0.25. That's less than 1, so that's going to be decay. Number 7, it's greater than 1. Not by much, but it is greater than 1, so that's growth. 8, less than 1, decay. The 6 isn't part of it. The b is the 5, but it's growth. And this one again, the 6 isn't part of it. It's the thing that's to the power that you're focused on. So that's a half. So this is again decay. All right. All right. Now the next few examples are going to be how you would basically apply the growth and decay formula to actually solve situations or try to get or try to estimate like future costs or what things will be in the future or in the past. You can go backwards as well. But for number 11, it says movie tickets now average $9.75 per ticket, but are increasing 15% per year. How much will they cost 5 years from now? So again, increasing is going to be an indicator of growth. So this is exponential growth. What is your multiplier again? That means they're asking us for b. So b is going to be, since it's growth, 1 plus the percent. So that decimal will be going to be 1 plus 0.15. So it's going to be 1.15. Is 975 your zero term or your first term? So they're saying that now it's 975. But a year from now, it would be 1. So that's when it's increasing. So I'm going to say our 975 is our zero term. That meaning it's before we're doing 1 year later. And then it says to write the explicit equation. It's going to be y equals. Let me write the formula again. It's a b to the exponent. A b to the x. All right, and a is the original amount. So the original amount is the 975. And then it's going to be 1.15 to the 5th, since it's 5 years from now. And then you could just put all of this in your calculator. 975 times 1.15 to the 5th. So my answer is $19.61. Now, because it's money, I normally say it around to the nearest tenth, but because it's money, we're going to go, to penny. So we'll do 1961. All right. Example 12. Sorry. A powerful computer is purchased for $2,000, but loses 20% of its value each year. How much will it be worth 4 years from now? So, is this growth or is this decay? It loses 20% of its value, so it's decay. My multiplier is therefore going to be B equals 1 minus 20% becomes 0.20. So this is 0.80. If it's 0.80, you can just put 0.8, but I'll leave it at 0.80 for now. Excuse me. Is 2,000 your zero term or your first term? So is 2,000 the value after 1 year? No, it's the initial value when I first purchased it. After 1 year, it's going to start depreciating. So I'm going to go with my zero term there. Write the explicit equation. It's going to be y equals 2,000 is my initial amount. Then it's 0.8 to the 4 years from now. So 4. Again, I'm just going to use my calculator for this part. 2,000 times 0.8 to the 4th. I get $819.20. All right. And the next two are a little trickier, so I'll do these two with you. And then we'll just skim over a few others. Again, today we're going to keep it kind of light. Tomorrow we'll do some that are a little bit more complicated. For number 13, it says, dinner at your grandfather's favorite restaurant now costs $25.25 and has been increasing at 4% each year. How much did it cost him 35 years ago? Okay, so increasing at a rate of 4% each year. So that's going to be growth. Now, this is a little weird because even though it's growth, they're asking us for what it was in the past. So we do have to go backwards. So it will get lower, but don't change the fact that this is still growth. What is your multiplier? It's going to be B equals 1 plus, again, 4%, 2 times to the left, it'll be 0.04. So it's going to be 1.04. The explicit equation is going to be y equals initial amount is 25.25, and it's going to be 1.04 and 35 years ago. So since it's 35 years ago, we're going to put negative 35 there. That's key. Not 35 years in the future, but in the past. So we're going to put a negative 35. And it says, what's the value of n in this case? N is the time with it. Sorry for my yawns. This formula is sometimes written as this to the n. So when they're saying what's the value of n, that's what they're talking about. The exponent there. We've been using x, so that's time. So in this case, it's going to be a negative 35. And then it's saying to solve it. So let's just go through and evaluate this. 25.25 times 1.04 to the negative 35th. And I get $6 and we round it to 40 cents. All right. Now the next one for the gallon of milk is going to require you to use some logarithms. That's why I don't like to do the exponential growth and decay until after the logs. So you can do some more elevated type of problems with it. All right, so for example 14 here, it says if a gallon of milk costs $3 now and the price is increasing 10% each year, so we already know that that's growth, how long before a gallon of milk costs $10? What is the multiplier? So it's increasing, so that's going to be B equals 1 plus 0.10. So it's 1.1. Again, you don't need the 0. I'm just going to keep it, but obviously 1.1 is fine. Write the explicit equation. The explicit equation will be y equals, original amount is $3, 1.10, and this is going to be to the x, because we don't know the time. Now, this question is different. It says, how long before the gallon of milk costs $10? So that's not going to go in for x. It's going to go in here for y, because you know what the cost is. You want to figure out the time if you know the cost. So we could put $10 in here for y. Oh, so let me answer the question. 10 replaces y. All right, so then we'll solve it. So it'll be 10 equals 3, 1.10 to the x. Now, in order to solve this, first thing I would do is divide by 3. You don't have to do it first, but I would. This makes it a little easier in the end. Divide by 3. So now I have 10 thirds equals 1.10 to the x. Now, no, this is not a situation where you're going to be guessing and checking. At this point, if we have an exponent that we're trying to solve for, that's the purpose of the logs. That's where that stuff comes in. So at this point, I'm going to bring in my logs, and I'm going to put, sorry, I'm going to move this up a bit. I'm going to put the log of 10 thirds. You can get a decimal for that. I'm just going to keep it as a fraction. It'll be a little easier. Is 1.10 to the x. So again, remember, we can always put logs in. As long as we do the log on both sides, we can always stick that in. Now, I'm going to use my log rule. My log rule, hopefully you guys remember, says that the exponent I can put in front here. So I'm going to rewrite this as log 10 thirds equals x times the log of 1.10. Now, I'm just going to go ahead and get the decimals for these just so we can see that we're on the same page. But so in your calculator, you'll just do the log of 10 divided by 3. And that'll give me, I'm just going to go 4 decimal places here. So 0. I don't need the 0. Oops. 0.5229 equals x, and then I'm going to do the log of the 110. That gives me 0.0414. Again, I'm going 4 decimal places. Now I want to solve for x here, so I want to get rid of this 0.014. It's going to divide by that. And then I do that division. 414. And I end up with an answer of x equals 12.63. So basically, in about 12.6 years, I would expect the milk to cost $10. It would take a little over 12.5 years for that to happen. Now, could you have done this without writing down all the decimals? Yes, depending on the calculator you have, you could have just done the log of 10 thirds divided by the log of 1.10. But again, I just wanted to show you guys the decimals to make sure you were getting the right values. So that would be that. And then the next couple questions, we'll do like 1 or 2 more, and then I'll just pretty much post this. And tomorrow, again, we'll do a few more harder problems. For number 15, it says identify the initial amount and the growth factor. So if you're given the equation, you should be able to pull out the growth factor and the specific amounts here. The initial amount will be the 712. Hopefully that's clear. That's our A. And the growth factor is the thing that's going to the power. So that's going to be 2.6. If it was like 0.8 to the x, it would say decay factor. But again, the next one, the population of a town is 2,700 and it grows 6% a year. Write an equation to model growth and predict the population after 3 years. So this is math that they actually use a lot in like city planning, as far as like how many students are expected at schools. They definitely use this type of exponential growth and decay to try to determine what the school population will be, to see if they need to build a new building, like things like this are math is used. So this is definitely some type of prevalent math that's used a lot in like real world. Anyway, it says it grows, so we're going to do b equals 1 plus 0.06. 1.06. And we calculate 2,700. All right, and we get an answer of 32, 15.74. So that would be how much? Why am I putting 0.74? Sorry, I'm thinking this is this is money. This is population. So because this is population, we would round it to the nearest person. So, oops. All right, and the last one we'll do is number 17, and then I'll let you guys go for today. 17, an investment of $4,000 triples every 3 years. How much will it be worth after 30 years? So tripling and basically that's times 3, but again, we need to get percentage. So if something is times 3, that's really 300% increase. So that's kind of what we should be thinking about B. So B is going to be 1 plus 3 because it's 300%. So B is 4. So again, don't just put 3 in there. It has to be 4. And it's going to be Y equals the initial investment is the $4,000. If you put 30 here, that would be incorrect. The reason that would be incorrect is because it says it triples every 6 years. So not every year. If you put the 30 here, that would be a tripling every single year. So it's tripling every 6 years. So basically you would just do the 30 and see how many times 6 went into there. That's going to be 5. So we're putting 5 into the equation. And we get 4,096,000. This is money. All right, so we'll stop here for today. Again, tomorrow I'll post a few more. Have a great day, guys.